going on, guys? Let's look at this problem right here. Here this question is asking, an antenna can be modeled as a Thevenin's equivalent having a sinusoidal voltage source V0 cos omega t and an output resistance Rout. Determine the average power delivered to the load resistance RL and plot the result as a function of RL. Okay, now let's look at the antenna. So let's say this antenna, and if we draw the Thevenin equivalent model of an antenna, that will look like this. We will have a voltage source right here, and then here we will have a resistance, and this one is Thevenin equivalent. Here the voltage source is equal to V0 cos omega t and Rs is equal to output Rout. Now what we have to do is we are going to connect antenna to the load. So let's if we connect antenna to the load, it's going to look like this. We connect here a load resistance RL and connected to the load, we will have a load like this. Okay, antenna connected to the load. Now the next thing is, now we have to find out the average power delivered. To find out average power delivered, we use this equation. IRMS is equal to for the power delivered to the load, the generic equation is this. Let's look at the generic equation. The generic equation is IRMS square times RL. Now IRMS can be written as VRMS divided by Rout plus RL. VRMS is equal to V0 divided by root 2. Then IRMS is equivalent to V0 divided by root 2 times Rout plus Rload. Okay, now this is IRMS. Then if this is IRMS, then we can find out the power equation. This is the power equation, IRMS square times RL. So IRMS square times RL. IRMS, we have found out the equation for that. That is V0 square divided by 2 Rout plus RL square, and here we will have RL, and that's it. This is equation 1. Let's say equation 1, and this is the equation we derived. And here we had to consider two things, like when the RL is small, the whole thing is the power is going to be small, the equation is small, and even the RL is big, it's going to be small because we have RL square in the denominator, so that's going to make this one small. So in both ways it's going to be small. If we find the derivation, so we can say the RL between 0 and infinity, when the RL is between 0 and infinity, there will be a peak. To find out the peak, we can differentiate this equation. If we differentiate this one with respect to RL, we are going to differentiate this equation, V0 square RL over 2 Rout plus RL square. That is equivalent to V0 square over 2 Rout plus RL square minus V0 square RL over Rout plus RL square. Okay, let's go ahead and continue. Here if we put this one, V0 square over 2 Rout plus RL square is equivalent to V naught RL over Rout plus RL cube. Rout plus RL divided by 2 is equal to RL, and if we simplify this one, here we will have Rout plus RL is equal to 2RL, therefore RL is equal to Rout. Now we can say that the maximum value of power is obtained at RL is equal to Rout. That's what we found out from this derivation. So if we plot this one in a graph, it's going to look like this. When we have power like this, the power maximum is going to occur at Rout, and that's it. That's what the question is asking. Plot the result as a function of RL is equal to Rout, and that's it. I hope you guys find this video helpful. Thanks for watching, and if you are trying to learn electronics, there are a bunch of videos in my playlist. I hope you guys watch that too. Don't forget to subscribe. See you next time.